Hello friends, today we are going to see about another machine learning algorithm that was near naive bias. That was naive Baye algorithm. Naive Bayes algorithm. By using near Bayes algorithm, we can perform both binary and multi-class classification, and this algo use and it will work on based on probability and Bayes theorem. Probability and Bayes theorem. By using this two mathematical concept, it will perform classification. Before in this video, this was first part. In this video, we are going to see about some mathematical formulas begin this naive bias, naive Bayes. In the second part, we are going to see with some example. Let's see the mathematical formulas begin naive Bayes. Before, we need to understand what is difference between independent variable and dependent variable. Independent, we know about independent variable and dependent variable. We have to understand what is about independent event and dependent event. Okay, let's take an example. When we rolling a die, we can get 1, 2, 3, 4, 5 or 6. Whenever we rolling a die, we will get any of this value, and this event is across independently, and whenever we apply probability on rolling this die, we will get, for example, probability of getting 1 is 1 by 6, because there are 6 elements are there. Whenever you rolling a die one time, you will get 1. We will get 1 at probability of 1 by 6, and probability of 2 is 1 by 6, and probability of 3 is 1 by 6. The probability of getting 6 is 1 by 6. We all know about that, but this event is does not impact another event. First, we rolling a die, we can get any of this value with the probability of any of any corresponding probability. Then whenever rolling the die another time, we will get any one of these two, any one of this 6. Let's take another example for independent event. We already see that an independent event does not impact another event. By understanding that, we can easily say that a dependent event will impact another event. Let's take an example. Let's take an example. We have a bag. The bag contains 5 fruits. Three fruits are orange and 2 fruits are mango. We want to find what is the probability of taking orange, and after taking the orange, then after that we want to take mango. We want to find probability of taking mango and then taking orange and then mango. Okay. In the first event, we need to we want to take orange from the bag. So the probability of taking orange at first event was, let's denote orange as in a star. Taking an orange is 4/5, because totally there are 5 fruits. In first time we have to take one of the fruit, so that after taking that we have a chance of there are totally 3 oranges, totally 5 fruits. Then the probability of getting an orange is 3/5, because there are 3 oranges out of 5 fruits. So probability of getting orange at first event is 3/5 at first event. Then after that, there are, in the second event, we have 2 orange and 2 mango. The probability of getting mango at second event is after the first event happened. That means the probability of getting mango given already orange was taken. The probability of getting mango given already orange was taken. After that, after done first event, we have 4 fruits, then 4 at denominator, and getting mango is have probability of 2, then 1/2 at second event. It was happened in second event. This is called as conditional probability. That means the one event is dependent on another event or impact on other event. One event is impact the other event. This kind of scenario, the conditional probability will be applied. We can see in another word, the probability of taking orange and then mango equal to probability of taking mango and probability of taking mango given already orange was taken. The probability of getting taking orange into probability of taking mango after orange, before given that already orange was taken. Okay, this event was an dependent event. But now we can see about Bayes theorem. The probability of A and then B is equal to probability of taking B and then A. That means whenever we try to, in first event we taking orange and in the second event we taking mango. This event as a probability, the same thing will be the same probability we will get whenever we taking mango first and then orange. So we consider this scenario, so we equating this after applying conditional probability and probability of taking A and then B is just consider this formula, just apply in this, we will get probability of A, probability of B by A equal to probability of B into probability of A by B. We can equate this after we a probability of A is moved to this side, right side, we will get probability of A by B by A equal to probability of B into probability of A by B divided by, after this element is moved to right side, we will get probability of A. This is called, this formula is called Baye theorem. Okay, let's see an example. We have a data that contain independent element x1, x2, x3 and x4, and we have a dependent variable y. Depending upon this input variable, this event will be happen. Depending upon this input data, it will affect the output data. Whenever you are applying Bayes theorem to this data, that means this element impact this element, that means it will affect this. So probability of uh, output or the probability of y when probability of x1 x2 and x3 x4 happen is equal to probability of y into probability of x1 comma x2 x3 and x4 divided by y and overall divided by probability of x1 x2 x3 and x4. Okay, we can consider this as constants, so it will be same for any of this condition. That means, let's take an example. We have a data set x1 x2 x3 and x4 and x4 and y. We have data set like this, and for the first data we will get s. For second data we have get no, and for third data we get yes. Let's we will consider this. Okay, let's find probability of getting yes when the x1 x2 we having x1 x2 and x4, it will be probability of yes into probability of x comma x1 x2 x3 x4 by s divided by probability of x1 x2 x3 and x4. Let's compute probability of no when having an x1 x2 x3 and x4. The same formula will apply for this condition. Probability of no into probability of x1 and x2 x3 x4 divided by no and divided by probability of x1 x2 x3 and x4. We can write this probability of x1 x2 and x3 as probability of x1 into probability of x2 into probability of x3 into probability of x4. Like that, like this we can write this probability. So by seeing these two conditions, the denominator as have a same in a same form, so we can consider this as constant. So we will eliminate this denominator. We can compute this only. Okay, this is the by using this Bayes theorem we will decide depending upon the input data what will be our output by using this formula. We will see this the real time calculation in another video. Thank you. what we by using Bayes theorem, how does the Baye algorithm will work. We can see with an example, real time example in another video. Thank you.